City Rail Link is a landmark achievement for Aotearoa, a project that's reshaping how Tamaki Makaurau Auckland moves and grows. What makes it truly special though is the calibre of the people behind it. Their skill, collaboration and commitment have turned an ambitious vision into reality. Here's Kieran to tell you more.
Kia ora, I'm Kieran Kliski from WSP, one of the Link Alliance partners on the City Rail Link project. This work brought together some of the best minds in engineering, design and digital innovation. Being involved in CRL was incredibly rewarding. It was a significant undertaking and we're all immensely proud of the people who have brought it to life. Their mahi, dedication and passion made it all possible. Let's meet a few of them from WSP and hear what it took, the challenges that they faced, the teamwork that carried them through, and their smart thinking behind delivering something truly extraordinary and transformational for Tamaki Makaurau Auckland. Then I understand you're involved in the digital modelling and design processes for CRL. Can you share with us how digital tools were used to solve some of the complex engineering challenges?
One of the biggest challenges was coordinating the design. Everything was modelled in 3D and we had over 500 BIM models. BIM models are digital representations that incorporate 3D geometry with structured data. We pulled together all of the BIM models into one federated model, so we could see how everything fit together across various disciplines, designs and software. That made coordination and construction a lot easier and helped us identify and address issues earlier. It also meant we could optimize materials and construction planning, helping maximize sustainability and reduce the carbon footprint.
Cohen, in your role as Civil and Utilities Lead, can you give me an example of an engineering innovation on CRL that you think will influence future projects?
One area where we pushed technical boundaries was in designing large stormwater drop structures. Basically a large vertical shaft that takes the stormwater safely down into deeper underground pipes. Because of the significant flows, the usual methods weren't appropriate, so we created specialised features to release energy as water drops into the very deep manholes. We also used advanced computer modelling to make sure that the downstream pipes worked as intended. It's an approach I'm now using on other projects because it gives much more certainty when things get bigger and more complex.
Let's move on and hear from two of our human-centred design specialists, Jared and Louise. Their work plays a crucial role in how people experience and interact with CRL. Jared, what was unique about applying a human-centred design approach to a project like CRL?
The unique part was designing a system that works smoothly for every user. We ran VR evacuation simulations with a range of independent participants to capture real evacuation behaviour, so we could test design options using evidence, not assumptions, and see exactly where people paused and hesitated in the tunnels. That led to practical changes like clearer wayfinding at emergency exits connecting the tunnels, which reduced trial evacuation time by 20%, about 39 seconds. It also shows the design works for people with a range of access needs.
How about you, Louise?
For me, the unique part was understanding how differently operators work compared to the traditional control room model. Long rows of desks facing a big video wall just didn't reflect what people needed day to day. Shifting to a pod-style layout made the space far more effective and better supported everyday communication and critical decisions. Seeing the system in action during testing really confirmed we'd made the right call, and it's great to see the approach already influencing other projects.
Next, let's meet three of our engineers and hear about their experiences. Andrew, you are our mechanical discipline lead on CRL. Can you tell us what made designing mechanical systems on an underground rail network so technically demanding?
Sure. It required an extremely high level of reliability. Every system has to support the rail safety case, which means there's a backup available to take over. If one part stops, another one needs to kick in immediately to maintain the network safety. Every component had to fit, function, and integrate perfectly. It was complex, precision engineering work, and I really enjoyed working with our Link Alliance partners to help make sure that the systems like the ventilation and the escalators were ready for the demands of New Zealand's first underground railway.
Hi Jane. As a structural engineer, what aspects of CRL really pushed your engineering thinking?
I think working out how to build an underground station in such a tight space was a huge challenge. We were fitting the structure between existing buildings and permanent retaining walls, so we had to balance the structural requirements with what was physically possible on the ground and stay adaptable as conditions changed. A good example of these tight constraints was here at Karanga Ahape Station. To reach the platforms 33 metres underground, we had to build 2 deep, narrow shafts. That made it really challenging to fit everything in: the structural walls, the beams and slabs, the 3 levels of escalators, the lift shafts, and the ventilation systems needed to run the trains, all within a tight space.
Now Jared, I recall you worked on the CRL project as a WSP intern. What did working on New Zealand's largest infrastructure project teach you?
Being given the opportunity to work on such a large, fast-moving project so early in my career was great. Walking onto a site with so many disciplines, teams and decisions happening at the same time was energising. It pushed me to learn quickly, communicate confidently and collaborate with different people. It helped shape the way I work now and the kind of engineer I'm becoming.
Catching up with Aotearoa, one of our design leads, collaboration played a huge role in bringing the tunnel design process to life. What was the key part of that process?
What really made the difference was how open and cooperative everyone was. Across the whole project, not just tunnel, people were willing to sit down together and work things through. The tunnel construction team especially were great to partner with. That kind of teamwork turned big technical challenges into something manageable that we could genuinely enjoy solving. A great example was when we tunneled under the Huia water main. Design and construction work as one team, reviewing ground condition, monitoring data to optimize the approach and manage the risk of construction impact on the water main.
Staying with the theme of collaboration, Stefan, you were WSP's architectural lead on the CRL project. Can you share with us how collaboration across the Alliance influenced design decisions on the station?
Well, as Link Alliance's architects, Grimshaw and WSP worked in partnership with City Rail Link Limited and with Mana Whenua to embed Māori principles at the heart of City Rail Link. This was a true partnership to translate our marama into spatial, material and urban design outcomes, not just a symbolic gesture. Each station tells a place-based cultural narrative through naming, materials, art and form, providing an immersive customer experience and natural wayfinding. Through the Alliance model, we were able to bring contractors in early to test ideas with Mana Whenua artists with prototypes. This helped protect the cultural and civic intent while keeping delivery practical. Together, the station set an international benchmark and are helping drive regeneration and future transit-led development in Tamaki Makaurau.
I hope you've enjoyed hearing from some of the WSP experts who have helped shape this incredible project. CRL is one of the largest and most complex transportation projects ever undertaken in Aotearoa New Zealand.